metal alloy, bronze, brass for copper, carbon steel, stainless steel for iron, and aluminium. Pure metal. Metal are ductile and moldable. Although metal have a lattice structure, but they have little restriction among this metal iron. So, one layer of iron can slide past over another layer, so that metal can be hammered into shapes or drawn into wire. So student, I hope you still remember early we learned metal, that metal are in a nice alignment structure, like a nice alignment box of orange. So they have a slip plane. When you apply force, it can slide past over another. And now let's talk alloy. What is alloy? What is property of alloy? Alloy are harder than pure metal. Alloy are harder than pure metals. When pure iron, copper or aluminium, all these soft metal, and by you adding small amount of other element to it, you greatly increase the strength and hardness. This is alloy. When you add small amount of other substance into pure metal, now you greatly increase the strength. That's alloy. Why? Because by adding a different size of an atom, what will happen? You disrupt the orderly arrangement of atom in this lattice. You disrupt this orderly arrangement of atom in the lattice. So you prevent them from sliding over each other, and you block this slip plane. So we're going to talk bronze, brass as alloy of copper, which you expect they are much harder than pure copper. Stainless steel, alloy of iron, they're much harder than pure iron. Carbon steel are even harder. So student, please remember this orderly arrangement of atom in this lattice. When you put different size of atom to it, they will disrupt it and you will make it harder. Now I'm going to talk about alloy of copper, and I'm going to talk two types, the bronze and brass. Now let's start off with bronze. Bronze is a copper, but you add small amount of tin. Once you add tin to it, they become much harder alloy. And that's back into the Bronze Age. They are strong enough to make into a shield or armor, or used as a knife or as an axe back in those days. Bronze also have a property. They're very good on casting into a mold. So they can, and this mold casting, you will heard a lot of bronze statue. These bronze statues are very durable, last hundreds of years. Now we're going to talk brass. Brass is another type of copper alloy. Instead, they adding zinc to it. When you're adding zinc to copper, now they also become very strong and they resist for corrosion. As example, like the screw, the nail, and they also have one very special property. They are very attractive. They look so golden look. So you can see of the saxophone, the doorknob, the key ring, they look so goldish, but they're not gold. They are brass, and they will look like gold, but they are very strong, and they are stronger than gold, harder than gold, and very lasting. Now I'm going to talk steel. What is steel? Steel, when 99.9% of the iron pure, that's called steel. When iron pure to the extent of 99.9%, we call it steel. And steel always tend to add small amount of carbon to it. And this small amount of carbon, you really change the property of steel. And you make it, the rule is when you increase the proportion of carbon, you increase the strength and hardness of that steel. Why would it be like that? Because if you look onto the structure of carbon, you look onto the carbon. Carbon is on the periodic table of the period 2. It is a small atom. Iron is on the period 4. They have 2 shells bigger. Look at iron. Look at carbon. Carbon of this small atom, they have 4 bonds. And these 4 bonds, they nicely fit into the whole of iron. They nicely fit into the whole of the iron, and which can block this slippery plane and make the iron totally unmovable. I give example. When you have an iron, you drop something very heavy onto the iron, and what will happen? When you drop these heavy things onto the iron, remember, iron have this nice slippery plane, so they can bend and move. The iron atom can bend and move. So now they change shapes. They're not very hard. But what about if I put carbon into iron, which called carbon steel? What will happen? We watch. In this case, you can see this carbon, they gap in the middle of the iron atom. So this slippery plane is blocked. Now if I drop something heavy onto this carbon steel, and you watch, you just cannot move it at all, because they have no slippery plane that the carbon atom can move, which make it to be a harder and stronger metal. Steel. These carbon steel are very, very useful and very, very strong. And when you add 0.25% of carbon into this steel, you can make it into a chain, an iron chain. They are much harder than pure iron, yet it's still slightly moldable and ductile, but they are strong. This is called mild steel. When you put 0.5% to it, they call medium steel. They call medium steel, and they are hard and strong. They use it for building structure as for the bridge, which can support a weight of 1,000 tons without bending. So this medium steel we also call it for structural steel. If you put 1%, about 1% of carbon to it, we call high carbon steel. They are extreme hard and strong. Extreme hard and strong. This is where you can use it to making a strong knife, like those butcher knife, they can cut bones. Or the machinery tools like the drill, they can cut stone. They're so strong. But can you put more than 1.5%? No. More than that, they become brittle. Still, there is another common of steel they use. That is called stainless steel. As iron is so strong, but iron have one disadvantage. That is, iron tend to rust easily. But when you add chromium and nickel to this iron, now they become stainless steel. And stainless steel do not rust. But stainless steel are quite expensive too. So they used to making for the watch belt, or for the cutlery, or for the spoon and fork, or sometimes you see those kettle for water boiling, they also make of steel, the stainless steel. Now we talk aluminium. Aluminium actually are the most abundant on lithosphere. The most plentiful, yet very, very hard to extract, because until the 20th century, we cannot use it. Aluminium comes from the ore called bauxite. And aluminium, if you look onto the activity series, they are very high and very, very hard to separate it from the mineral. Pure aluminium, they are much rare. You never see an aluminium nugget. Yet, you can see gold or silver nugget. So, back into the olden day, 18th century, they used to put it and give it to the queen. So, on this picture, the middle part is the aluminium. Outside is gold. Further is the platinum, white gold. And you can see how precious those days of aluminium. But now, we have until the 19th century, we have the method of extract aluminium now by using electricity. And once we have this skill, now the cost become drop and it become widely used. If you look onto aluminium, aluminium have one special property most metal don't have. They are light. If you look onto the aluminium, they are on the period 3 and the weight is 26. Compared to most structural metal on this group. All the metal will, if you look onto this group, this structural metal, they all double or more than aluminium. So aluminium is one of the lightest metal. And also another advantage, they don't rust. They resist corrosion. Aluminium have a lot of use, like for the window frame, and now for the cooking pan, and even for your drinking can. They all made of aluminium. They have an advantage of its lightness. Aluminium, when you alloy it, aluminium itself is a soft metal, as on early example with other metal. But once you alloy it with titanium, you can greatly increase its strength. It can strong enough to use it to build the aircraft body because of this light, and yet they become very strong. So they used to build the aircraft body as well as for the racing bike or boat can make of aluminium.